For the project, I chose to look at the question presented here. And in baseball, the infield is a square that is 90 feet on a side, with bases located at 3/4 and home plate at the fourth. If the catcher at home plate can throw a baseball 70 miles per hour, how many seconds does it take for the thrown ball to travel from home plate to second base? And because this question had a diagram already provided with it, I knew that the diagram would be a key part of my problem-solving strategy. So the first thing I did was I added information into the diagram. So I added the fact that all sides of the square were 90 feet. And the question is asking about the throw from home to second. So I drew a dotted line in from home to second and let X represent the distance between those two bases. Because I only needed some of this information, I redrew the diagram as a right angle triangle where the vertices are H as home plate, F as first base, S as second base, and again X represents our unknown distance from home to second. And knowing that I had a right angle triangle and that I needed to find the length of one of the sides, I chose to use Pythagorean theorem, which is a squared plus b squared equals c squared. And the important thing I knew I needed to remember in Pythagorean theorem is that c squared always has to be the hypotenuse, which is the longest side. In my diagram, that's x, so I knew that x had to be c, and the 90 feet for either of the other legs could be A or B. The order there didn't matter. So I got 90 squared plus 90 squared equals x squared, and I evaluated to get x squared equals 16,200. And I wanted to know what x was, not x squared. So what I did was I took the opposite, the inverse of x squared, which would be the square root, and the square root of 16,200 is either positive or negative 127.279 approximately. So my equal sign with those squiggly lines show that it is an approximate answer because I rounded. Now we're talking about a distance, so we can't have a negative distance, so I rejected the negative 127.279, and that left us with an answer of positive 127.279 as our distance from home plate to second base. Now I filled that information into my diagram, and the diagram looks complete, so I was somewhat stuck as to what to do next. So I took a moment and I wrote down everything that I did know in a sentence. And we know that the ball traveled 127.279 feet at a speed of 70 miles per hour. And because we had a distance and a speed, I remembered the DST triangle from science class. In this triangle, I filled in the known information, which was the distance as 127.279 and the speed as 70 miles per hour. And that left us one unknown, and that unknown is time. And so this triangle diagram translates very well into an equation. And so t is our unknown, so t ended up on our equal sign, on one side of the equal sign, and we took the top, and that became our numerator, and the bottom 70, which became our denominator. And then I evaluated this to get 1.8. And this doesn't have a unit attached to it, but when I thought about it, time, looking at where we see time here, this means that it would be 1.8 hours. So I knew I did something wrong there because that's not a reasonable answer for the amount of time it takes to throw a baseball from home plate to second base. Otherwise, baseball games would be even longer than they already are. So I had to reevaluate. So going back to my original statement, I noticed that I had a distance in feet, and a speed using miles per hour. So I needed to convert those miles to feet. And using the Google unit converter, I found that 70 miles is equal to 369,600 feet. So 70 miles per hour is equal to 369,600 feet per hour. And the final answer for this question needed to be in seconds. So I took my speed in feet per hour and divided it by 3,600 to get feet per second. And I divided it by 3,600 because there are 3,600 seconds in an hour. And I know that because in an hour there are 60 minutes. And in each minute there are 60 seconds. So 60 times 60 is 3,600. And I ended up getting an answer of 102.667 feet per second. So now that I had my speed and my distance with units, I changed my statement to say we know that the ball traveled 127.279 feet at a speed of 102.667 feet per second. And I went back and drew in my triangle and filled in the distance and the time. I translated this to an equation in the exact same way as I did before, and I got that the time is equal to approximately 1.24 seconds, which seems like a much more reasonable answer, as I thought that the ball would have traveled within 1 to 2 seconds. Just from my knowledge of baseball, it seemed like a correct answer, so I wrote my therefore statement, which says, therefore, the ball traveled from home plate to second base in approximately 1.24 seconds. And that was my final answer, so I knew I was done the question.